Remember I was talking about the oil filter?
Yeah.
Want to point this stuff for that?
Sure.
There you go.
Just show me how to use it, okay.
Camera has a button.
Okay, yeah. As you can see, this is R134A. Okay. Now, R134A mostly in the industry is used with refrigerators. Okay. I don't know why they decided to use that as refrigerant in here, but anyway, if you notice, this thing here is the condenser barrel, and it goes into here, it runs right through it, it comes back, and it's sent back. Okay, now, right at the end, you will see that there is sensors right in there. And what is telling mainly the computers on board is just for safety. It doesn't do absolutely anything else other than sense temperature. When you sense it that the temperature of the water is higher than it should be for safety of operation of the system will shut down. Okay? So what you see right at the end is nothing but safety. It doesn't absolutely anything else. There is a computer that starts the pumps, but as far as what are those things for, is just for safety. That's correct. Now, the oil system starts in here. That's a solenoid that allows the water to start flowing. And you get into that motor. That's the little motor that pumps the oil. So if you notice, it's down on the, as I was explaining you up in a classroom, it's right at the bottom of the condenser. The reason why it was placed in there is because the water is only not a maximum of 85 degrees, perfectly capable of cooling also the oil. Okay. So the oil starts being pumped out there, and there is an oil sensor that it senses that the oil is flowing, and it will start the compressor. Now, if you notice, this, by the way, guys, is not a dryer.
Muffler?
That's a muffler. Correct. And it comes into there. Okay. Now, the refrigerant is picked up as a liquid right in there, and it goes back and it starts shooting into the side. Let's see.
The refrigerant goes into the compressor?
Into the compressor, yes.
Okay.
But if you notice, this is the discharge of the compressor.
Discharge, okay.
This comes out as hot gas, and is run into there. Now, it enters the barrel as a hot gas, and as it starts going down, it'll become liquid, and it'll be picked up off right there. And from there, it should shoot into the compressor, and then it starts doing, it starts being shoot into here, which is the cooling barrel, and it starts doing its thing. Now, as it comes back, it'll come back right through there. That's why you don't see a suction line, because the suction is right there. So that is basically what the system is. If you notice, it is really no difference than the unit that you see now there. Basically, it's identical to a 2-ton, 4-ton, 5-ton system that you guys look into it. Going into this, I can tell you a story. I started as a air conditioner with Sears. Now, Sears only does domestic air conditioning. So it's the largest that they service is 5-ton. Then I started with the district, and the very first trouble call that they sent me to, I asked the plant manager, I said, hey, where is the air conditioner? He says, oh, it's up on a roof. So I go up on a roof, and I go and said, Jesus Christ, I see the thing. This air conditioner is bigger than my truck. I have a Ford Econoline, 3/4 ton, large, and that thing was larger than my van. And I said, oh my God, what am I going to do now? But if you really look at it, it's nothing but an oversized little air conditioner. So you have your discharge, goes into the condenser. The only difference is that this condenser is cooled with water, and then you have a liquid line. So now remember that I said that the TXV, the metering device, has 1,600 positions.
Yeah.
It's this little thing here. And if you notice, it's all electronic. The computer tells them, okay, move a notch, move 3 notches, move 4 notches, and it starts closing or opening as needed from a capacity of approximately 11% up to 100%. So this is the metering device, and if you follow it, you'll see it that it goes into this barrel here, which is the evaporator. And from there, that is thing, what you have learned, I mean, it becomes from liquid into a cool gas. And of course, it goes into the suction line. Now, that's the big suction line over there. So it goes right from the evaporator right into the. Now, that brings up a point. If you notice, there is no suction line to speak of. So, it is very easy for this system to slug liquid into the compressor. So that's why all the computers have to make sure that all that liquid has flash.
Okay.
Okay?
You have to keep the perfect superheat.
Yes.
And it's a screw compressor?
This is a screw compressor, yes. And if you notice, one is bigger than the other.
Oh, it is. It's big. Yeah. Slit.
Anyway, and that's basically, now, something that is important that you probably have even heard about. Notice that this is the liquid line. Now, if you follow this pipe, look where it goes.
Outside.
It goes outside the building. Any idea why?
It's a liquid. Some cooling.
No.
No idea.
That is mainly for the safety of you guys.
Oh.
Let's say that
There's a fire.
something happens and this gets so overheated that it'll rupture. Right in there, there is a sensor that it will open up before this rupture. And the gas, the refrigerant, will displace the oxygen. It'll push the oxygen out of the room.
Right.
Now you have no
air.
oxygen. So this is nothing but a safety. And if you notice, both of the units are hooked up to the same thing. So if there is a problem, the refrigerant will be exhausted outside the building.
I noticed they have two.
Yes, correct. So very interesting. There is now on a system that is, let's say, a 5-ton unit. You have high pressure cutout, low pressure cutout. That's it. On systems that are this big, now you begin to incorporate more safeties. The bigger and more expensive the system is, the more safeties that you start putting into it. And that is something that you guys will have to be learning as you go into the trade, is that wiring diagrams begin to get more complicated, mainly because of safeties. But it's still the same line. Okay? You may have, let's say, 2 safeties before it gets to the contactor. By the way, we don't use contactors in here. We use max starters. Now, what is the difference of a max starter and a contactor? The contactor, it has a coil. You apply 24 volts to it, boom, it works. A max starter, it has a sensor, an amperage sensor built in it. If it senses that it is drawing more amperage than it should, then it will kill the control voltage. So that's basically the difference between